nice to be with you today. I will get starting in a few minutes. We have 45 minutes or an hour?
Yeah, we have a full hour. So if you do like a half hour presentation.
Okay, and then we can have Q&A. Good. So don't hesitate effectively to log your question. We'll take them, I think, mostly at the end. And thank you, Kevin, for inviting me today. And I will present myself quickly. Jean-Sébastien Pegon from ID Quantique. I joined 3 years ago. I'm responsible for the Americas region and Western Europe for quantum safe security. I have a telecom engineering and physics background. Worked mostly 20 years in telecom in various roles from service management to product management, business development, and sales. And for ID Quantique, I'm mostly doing business development and sales as well. So we celebrated our 20th anniversary last year, and ID Quantique was founded in 2001, sorry, and by 4 physicists from the Geneva University. And Grégoire Ribordy, the CEO, is one of the 4 founders. We have offices in Seoul, Boston, and now Vienna, Austria, but the HQ is in Geneva, Switzerland. We are employees, mostly engineering scientists. Well, the last major round of investment was in 2018 from SK Telecom and Dutch Telecom. The good thing is that they are investing, but also using our technology. So it's a very interesting collaboration with our investors as well. So ID Quantique has 2 main business units, quantum safe security and quantum sensing. So quantum safe security I belong to, and the talk today will be mostly on quantum safe security, which includes quantum key distribution and the large generator products. And quantum sensing, I will have a few examples at the end of the presentation, but I would suggest that you contact us. We can organize maybe also a second talk on quantum sensing. So as you see, there is one domain of quantum which is missing, quantum computing. So we contribute with quantum sensing, we contribute to quantum computing, or we can connect to quantum computers securely through quantum safe security connectivity. But we are not directly active in quantum computing. So I think you had several talks, and already it's the biggest, clearly the biggest domain and biggest potential quantum computing. But quantum safe security has the advantage of having existing products and solutions that can be deployed today, as you will see, and I will show a few examples during the talk. So I looked in of course, healthcare and pharma. There's a lot of confidential information, whether it's patient medical records or IP information in the pharma industry. So we see that the cost of the bridge is actually, unfortunately, at the top for health sector. And one of the ways to protect, obviously, sensitive information is to use encryption. But as you know, encryption requires cryptography that needs to evolve over time, depending on the adversary computing power available. And with quantum computers being developed, clearly the full crypto suite needs to evolve, and we enrich existing crypto solutions with quantum technology. This is one really key role that we have in this domain. We are lucky to be in a domain, as you know, that is evolving and expanding. We see very interesting growth in various domains. So in the 3 main domains, quantum computing, sensing, and cryptography, they're all growing at different pace. But clearly, it's a very exciting times for quantum technologies having real applications. as I said, the crypto and encryption solutions needs to evolve because there are threats from quantum computers being able to bridge typically IRSA or Diffie-Hellman when they will be powerful enough. The threat as well today is that clearly if you get your data are stored and even encrypted, they are stolen and stored, they will be able to be decrypted later. So that's clearly the risk today that is on even encrypted information can be able to be decrypted. So there are several areas of evolution and improvement to improve existing classical, let's say, crypto algorithms. So post-quantum cryptography is one solution that is very important. So it's next generation of encryption, if you want, using also mathematical complex problems. And the NIST is expecting to release very soon the new standardized post-quantum crypto algorithm. It has been a 5-year process, and there will be anyway evolution, continuous evolution in this domain as well. We are users ID Quantique for post-quantum crypto, and we contribute to post-quantum crypto because it requires also really good quality randomness. So we provide quantum random number generators, and these random number generators, as you will see, provide a source of randomness from quantum technology that is directly, let's say, from the, I would say, inherent from the technology, as you can see. And the other domain is quantum key distribution, is distributing keys through quantum communication in a network that can be used typically by symmetric encryption, knowing that symmetric encryption resists to quantum computer attack. At ID Quantique, our approach is really to have a solution that can be used when we commercialize them, and quantum technology really introducing existing solutions. So the chips, for example, you will see have been included in, for example, in smartphones from Samsung Galaxy already in 2020, the first smartphone. We introduced quantum security, self-security in 5G networks. We deploy quantum key distribution networks in parallel of existing networks to enrich security. So I will go on some areas very quickly. I know the audience is various origin, and you can contact me, but if you need more details. But the idea of QRNG is to enrich existing random number generation solutions. Random number generator are used obviously in cryptography to generate keys that cannot be guessed and reproduced, that are unique, and quantum random number generator is a new source and solutions of entropy, randomness for generating cryptographic keys. So we have developed, we have a specific pattern to generate randomness out of light source, reaching a sensor on it, and then generating the randomness from this principle. Then, of course, we apply the post-processing. Here we apply like a DRBG, so it's a standard post-processing solution that is standardized by NIST, and the output is the random number generator. It's very fast because as we said, the quantum principle gives us direct source of entropy and randomness. So we reach megabit per second. It's a robust process. It's not influenced by external environments, and it's fairly simple that it can be integrated in a chip. So we have various form factors for this type of solutions, and and based on the different applications in various domains. And we are passing, of course, standardization tests, certification tests, like in the automotive, and in the healthcare. I imagine there will be also a need to go through some certification at some point. So an example of use of a random number generator chip is for IoT devices. IoT is also used in healthcare, hospitals, and for integrated combined with medical devices. So it's, for example, an application in the healthcare domain. I mentioned the smartphone application use case where we enrich the security of payment services thanks to keys generated by this quantum random number generator. In the data center and cloud environment as well, we have worked with Alibaba, for example, who integrated our QRNG chip to distribute randomness within the data center to different servers, like Linux servers, for example, that can benefit directly from this external source of randomness generated by the quantum source. So that's one area, is quantum randomness. There's also application in lottery and games, obviously. So there are many different areas. I imagine what's the interesting applications for Pharma. I think it's an healthcare mostly is introducing and enriching the randomness to improve the security of the medical devices. And here we work directly in this case with the manufacturer of these devices. So we're talking about hardware, of course, introducing the chip in various devices. So if you have any applications in mind where it's missing in your in sensitive device, that we can also work together and contact these manufacturers like Siemens or various manufacturers. Sorry. The other important topic where we are very active is for quantum key distribution. So as I mentioned, sorry, I need a drink. As I mentioned, the way asymmetric cryptography needs to be replaced by either post-quantum cryptography or quantum key distribution. And quantum computers can run shorter algorithm and reaching existing public cryptography. So quantum key distribution is the principle is exchanging qubit between Alice and Bob. We generate random qubits on Alice side, and we send them through a fiber optical, so standard telecom fiber optical link connecting Bob on the other side. And we have then a symmetric key available on Alice and Bob's side, with the interesting property of quantum technology that if you intercept the communication, you modify it. So you have a security that is ensured at the photonic level. It's widely recognized that you cannot clone photons that you would intercept, and you cannot eavesdrop the communication without modifying it. So that's this also principle that we use to produce our appliance and quantum key distribution device. So this symmetric key is one example of usage of the symmetric keys, clearly is for symmetric encryption. And instead of transiting keys through data communication network, that's the way today, the way it is done, using asymmetric crypto, you exchange your symmetric keys and then you do your symmetric encryption. In this case, we set up a parallel communication channel, quantum channel, and so the KD device on both sides of, this is an example in the data center with a point-to-point connection. And then these symmetric keys can be used to rotate and encrypt, decrypt the data on both sides, obviously. So we just announced in San Diego at IQT the launch of a new QKD device. So it's like an appliance, one new appliance, like a server type of format, and it's a Physics-based device, which allows for longer reach and higher key rate. So the typical distance between two endpoints is around 50 to 100 miles. And so with the Physics-based, we'll reach in the range of 100 miles, depending on the fiber network quality. And we are also increasing the key rate available on the endpoint. So it's the idea is to have more effective solution to build larger networks, such as backbone. And you will see that we are deploying 1,000-kilometer link networks today. So it's 20, 30, 50 nodes. And obviously we need to have also longer reach solutions. I won't go into all details of the product, but I think I mentioned the principle. If you want to have more details, contact me offline. This is a quantum key distribution device connected through fiber optical networks, integrated with existing encryption solutions. So that's also a very important point. The idea is not to replace all existing network infrastructure, but to complement with quantum key distribution networks. And we map existing network topology, whether it's mesh, ring, or star topologies, and we provide these encryption keys to the encryption devices that can be provided by different vendors, such as Adva, Thales, Juniper, Cisco, of course, Fortinet. So Hitachi ABB in the critical infrastructure domain. And the idea is that we worked with these network vendors so that we can combine smoothly our solutions. We are building and starting to build, as I mentioned, large networks. We started in Europe, for example, with 18 systems that are used for validating different use cases. And you will see there are use cases in the pharma, healthcare domain. The objective from EU is to have in 2027 a fully deployed network across Europe that can be used by public organizations to secure their sensitive data. So hospitals clearly are also potential user of this quantum communication network. We validated through the first phase of the project, we validated different use cases. One use case is to secure and offer long-term security for medical data. And this is clearly sensitive. There's a value. The value of medical data is very high. It's sometimes also mentioned higher than some personal or even financial data. So the protection that needs to be offered needs to be very high and long term, obviously. So in Europe we have, for example, GDPR regulation, and there is the obligation to ensure that you provide the highest available standards to protect and encrypt the data. There are many other sectors. Obviously, one is important is telecom, because as a pharma or healthcare enterprise, you don't necessarily want to deploy your own network. Clearly, you want to buy it as a service. So you will see we work with service providers so that they can offer the service to the healthcare and pharma sector. One use case that was deployed in Graz was with a partner called Fragmentics. The idea was to secure the connections and between two data centers through and two hospitals locations with redundancy of the QKD links so that we can encrypt the data end-to-end using quantum keys that are distributed over the network. We combine it as well, in this case, with ADVA encryption solution and our ID Quantique QKD systems. The interesting also application is for data center interconnect and for multi-use of quantum keys once they are equipped in the data center. So as a pharma or healthcare company, you can imagine to subscribe to a service to have your quantum keys available in different nodes of your network. And there is a possibility to share existing infrastructure, so quantum communication infrastructure, between different applications, customers, and having access to symmetric keys between the different nodes of the network. So you can define between which nodes and which customers you distribute keys. And you can, of course, ensure also a redundancy of the paths between the different points of the network. In South Korea, we are also deploying a 2,000 kilometer QKD network. And the objective also is to provide long-term security to governmental data and also validate different use cases in different domains. So we have deployed 3 use cases to protect biometric information or hospital information system, so IT, let's say, more related applications and health data. So these are examples of deployment that we have done in South Korea. We have a wide range of technology alliance partner. As I mentioned, we are expanding. So if you see that some of your device manufacturer, network manufacturer are not in the list, we can talk to them and see potential solutions to include and combine their solution with quantum technology, quantum security. And we are deploying our solutions for a wide range of domain. As I mentioned, service providers, critical infrastructure is an important one, utilities. We are also strongly contributing to research, different research program organizations, and we are keen to do more. So I cannot mention all our references, but as you see, there are known names, and large companies have a quantum program, whether it's usually including quantum computing and quantum security, sometimes also quantum sensing. What I would like to summarize on the quantum safe security side is that clearly the quantum technology can improve existing cybersecurity solutions, and there is a need to have an evolution in the encryption layer and the encryption protocols. So it's the right time to look, do I use asymmetric cryptography such as RSA, Diffie-Hellman, and how do I make sure my infrastructure, my data is protected and will be protected tomorrow. So we need to prepare this journey to have the evolution and upgrade of the infrastructure today. And as I mentioned, quantum randomness enrich key generation. Then it's enriching so your security, even using classical security solutions. And tomorrow we are deploying post-quantum cryptography and quantum key distribution. Our projects have already started in different domains. So if you are interested, you can contact me offline, and we can discuss obviously specific needs and scenarios. The last point I would like to mention briefly is our activity of quantum sensing applications and the application of our quantum sensing products for healthcare and medicine, life science. So we I will mention three main applications clearly. One is the precise fluorescence lifetime imaging. So we combine two of our products here to provide this efficient control and detection instrumentation on what they call next level film microscopy. So if you also want to have more information here of an example of use of the power single photon detection for film, let us know. There are applications in deep tissue imaging. So to have a non-invasive brain imaging with superconducting nanowire single photon detector that we provide. So you see the picture here of what we call the SNSPD. And the SNSPDs are also used by photonic quantum computer companies. And clearly quantum computing is also, as you know, very interesting and can improve research, pharma research, optimize existing computation problems. And so we are indirectly contributing to quantum computing development through our single photon detectors. I give you in 30 minutes a brief overview of ID Quantique. Our activity here, we are very concrete in terms of applications, as you see, of quantum technology. We have the advantage of having solutions that we deploy today and that can be proposed based on your use case and needs. So don't hesitate to let us know. And I think there was a few questions during my talk that I didn't have the time to read. So